Hello everyone, myself Sidharth Panda and I have my teammate Aditya Kamble, and we are going to present the final deliverable of our KBS project, the Knowledge Based Systems class. And it's about the US accidents where we have performed modeling and prediction to find the severity of an accident to predict the severity of a type of accidents. In this project, we have used the dataset from Kaggle, which contains 3 million rows and it is updated as of 4 months ago. And it contains the data from 2016 to 2019. And as you can see, we have all the columns, the 49 columns, and the size of the data set is 1.5 GB. And when we hear about accidents, we come across many questions like how did the accidents happen, and in which state the accident is, the number of accidents is higher, and then does the wind speed or wind direction contributes to the accidents, and then of course the weather condition in rainy days or in thunderstorms, the visibilities goes down, and for which the accidents, the number of accidents, they rise significantly. So these are the questions that came to our mind, and we tried to visualize using the data set. And for that, we used the Data Studio of Google. First, what we did, we exported our data set to the SQL instance, the SQL Cloud instance, and from there we took it to Data Studio, where we created the visualizations as the number of accidents per country, the heat map, which shows the wind speed, and as we can see, the south wind, and the number of accidents occurring due to south wind and west wind. Then calm. If we can see that if the where the wind speed is calm, then there are more accidents. So this is the user dashboard for the users or the engineers and for the companies who work on automated driving or have any other stuff that contribute, that can help to reduce accidents, and it can help them. And this shows the country-wise severity. We can see in California it's the highest, and this shows again the pie chart for the weather conditions that causes accidents. Now for using Google Cloud, what we did is that we used BigQuery to create the table and then execute SQL queries. So from our SQL instance, we extracted the data and created our table called accidents, and where you can see, and what BigQuery did is that the BigQuery, it converted the whole data set into table, and it gave the schema details and everything, and you can see the preview of the data. Since it contains like 3 million rows, so it takes some little bit of time to load. So this is the schema that created, and we again changed some of the data types of the columns that we are going to use in our prediction and modeling. And then after that, we used the BigQuery API to fetch data into our cloud, into our AI notebook in order to execute and perform the EDA. And this will be presented by Aditya itself.
Yeah. Hello, everyone. Thank you, Sidharth. So we'll move on to EDA now. So for the EDA, we consider the pre-processing of the data. So because of the lot of the data has null values, so we need to remove those data from the data set. And also we also worked on the feature engineering and feature cleaning. So if we see the Jupyter notebook for the EDA, so we started with the data cleaning initially. So we have explored the data set, because EDA is all about exploring the data set. What are the columns over there, and what kind of columns are provided by those columns, and which features are actually important to our prediction, right? So this is our normal EDA. This is one of the point I want to elaborate the feature generation. So here it is. We are creating one new feature called day of week, right? Because we have the time and date for all the accidents, right? So we need to create one column which will represent the day of week only. Like it will just contain a Monday, Tuesday, or Saturday. So yeah, I've created one column over here, day of week. And if we scroll further down, we can see there is one EDA which will explain there will be more of an accident on weekdays compared to weekends. Yeah. So yeah, this is also state-wise accident heat map. So we can see over here we have a lot of accident in California. Then we have accidents in Texas, and all the other states have a lower rate of accident compared to these two states. Yeah. So yeah, this is also a county-based distribution of the accidents in the California specifically. We have counties like Los Angeles, and then San Diego, Metro. Yeah, so like that, and the most of the accidents are happening in the Los Angeles. Yeah, so these are the pie charts to explain the weather conditions affecting the accidents. So as we can see, the clear weather condition has most of the accidents occurred. Then we have mostly cloudy and partly cloudy weather conditions. Yeah. For the wind direction, we already seen the user dashboard, right? So this is the same. Then we test accidents. So yeah, so this is the one of the graph. Yeah, bar graph. So here we can see we have the lot of accidents happening on the weekdays, like Tuesday, Friday, Wednesday, and we have very low number of accidents on the Saturday and Sunday. Yeah, so one of the graph over here in the pie chart, if you scroll above, yeah. So this is the related to stop sign. So in the 96% of the cases, sorry, 98% of the cases, if the stop sign is not there, then the accident is happened, and if the stop sign is there, then no accident happened. So these are the main observation for the EDA, right? California has maximum number of accident in US. Then we have the cloudy weather condition, which has impacting more for the accidents. We have 95% accident happen if stop sign is not there. Most of the accident happen when the wind condition is calm. So yeah, basically these are our analysis if we just look into the data set. So this is our final EDA. This is a word cloud basically, and we can see the most of the reasons why the accident happened. Like lane is blocked, then due to some right lane or left lane or closed lane. Yeah. So yeah, hand shoulder. Yes. So these are some reasons you can just relate to using a natural language processing. Okay, so yeah, so we'll move on to detailed ingestion plan. So I already Sidharth has explained how we did the data ingestion. So we started with the CSV, which we got from the Kaggle, and then we imported that CSV into a storage bucket. We moved that data to the Cloud SQL then, and use that data for user dashboard presentation. After that, we copy that data to BigQuery because we can perform lot of analysis and queries using BigQuery, and we use that BigQuery to create one data frame in the pandas and which will we will be using for model prediction. Yeah, so this is our final severity prediction for this project. So after doing the EDA, we came around like these are the some features, right, which are useful for predicting the severity of the accident. Because yeah, so what will be the use case for this one is, right, some of the automated vehicle companies like Tesla and all those car companies, they will collect all the data, weather condition, the wind direction, and they will use this model to give the suggestion to the user which these weather conditions are good for you or not. So what will be the severity of the accident if it happened on the scale of 1 2 3 4. Yeah, so we just load the data using Python pandas, and now we have used a cleaning and feature generation in the pandas only because pandas has more of a detailed methods which can help us to create features and clean the data more easily. Then we use converted that data frame into a Spark data frame. We have used the PySpark over here because PySpark has PySpark can handle a lot of data at a time, and it is basically invented to handle real-time data. As this data is coming from the sensors, so we need some real-time data handler. Pandas is okay if we use the statically we have the data in a static database, but in the real-time events we need a PySpark because it can handle the real-time events very easily. So that's why we wanted to build our model in the PySpark. So that's why we converted the cleaned data frame into a PySpark data frame, and then we started creating the columns. Okay, the columns are over here like feature columns. So if you scroll up, you can see the features columns are like yeah, these are the feature columns. So first is TMC, then longitude and latitude. Then we have distance travel, the temperature and humidity. So like that. And we use this Spark data frame and converted those feature into one feature column, because in the Spark we need to create one combination of column which called features. And for output we have used the severity over here, label column. So it will be our prediction column basically. Yeah, so we have used three prediction classifiers here: the random forest, decision tree, and normal logistic regression. Yeah, so we executed we converted the data into training and testing data set using 0.7 and 0.3 margin. And then we use the training and prediction using three types of classifiers. So we got the results is actually around, if you use the random forest, is around 65 if you round up. And if we use a decision tree and logistic, which came to 70% approximately. So yeah, so this is our major finding that we can apply to a real-time problem statement. So getting all the data from the automated vehicles and sensors, and we can just plug it into our cloud infrastructure using PySpark and just get the prediction very easily. Yeah, so these are the references. Mainly we have used a Kaggle data set for US accidents. So it is around 3 million entries. And yeah, that's it from my side. And thank you for viewing our presentation. I hope you liked it. And yeah, the special thanks to Dr. Thompson for encouraging us to do this project and work on the Google Cloud, and use those components very heavily, and how we can incorporate that in our day-to-day problem solving. Yeah, that's it from my side. And I will get back to you, Sidharth, and Sidharth will yeah.
Yeah, thank you, Aditya. So that's all for our presentation, and thank you for listening.
Yeah.